Hey everybody, this is Larry. This is day 7 of the June Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. That means that we're coming up on 1 week. Congratulate yourselves a little bit. 1/4 and a little bit less of the way there. Anyway, today's problem is min cost climbing stairs. So you're given an away cost where cost of I is the cost of the I step. Once you pay the cost, you can climb 1 or 2 steps. Okay, so you either start with index 0 or step with index 1. So you start on a 10 or 15, and then you go 1 or 2 steps up, or just up, I guess. But okay, start at 0, stepping only on ones and skipping. Okay, I mean, this is pretty straightforward as far as dynamic programming problem goes. You can do it forward, you can do it backwards, however you like, really. It's just about defining this recursively, or if you want to upsolve yourself with bottoms up or whatever. This is probably a good time to practice it. Yeah, I mean, I think this is it. It's just phrasing itself in terms of everything. And now that I have all the information, we can just go, okay, let's define the min cost of, let me set up my keyboard, of current step. And if step is equal to, the top 4. Okay. Do we have to pay on the top? Pay that cost and go to the top. Okay, so we don't. So let's set up n is equal to the length of cost. So if this is on the top 4, we're done, right? That's return 0. Otherwise, we just have to we literally just transcribe the problem, because we're doing it in a brute force kind of way, really, except for that we memorize. That's how I always try to teach it, is that try to figure out a way that you're doing brute force in a way that you're reusing results so that you're able to just memorize it. And that's basically what I'm doing here, is that, okay, once you're on the ith step, you can either climb 1 or 2 steps, right? So the cost is equal to, oh, whoops, I guess this is the name of the thing. So, okay, C is equal to cost of the step, otherwise. And then here, you can climb 1 or 2 steps after you pay that cost, right? So, yeah, so because this part isn't going to be different, we just want the minimum of going 1 step or 2 step. And then we just return the C. That's pretty much it. I guess you can actually go directly, but yeah. And then at the very end, just return from either, the problem tells you, right? You either could start at step 0 or step 1. And that's pretty much it. And of course, this isn't going to run fast enough, because I kind of gave it away, which is that you need to memorize. And also, of course, make sure that this is out of bounds. I mean, there's a couple ways to do this, but it's fine either way, which is that if step is greater than or equal to n, that means that it's out of bounds, so you return maybe just like infinity. And I always write this because I don't know, I'm weird. I like to keep everything in int, because the full version of infinity is, as you might know, did I misread this one? Maybe I misunderstood this one. Hang on. Give the cost of I've step on this. Once you pay the cost, you gotta climb 1 and 2. So why can't you climb 0 and then take 2 steps? Did I misunderstand this? Huh. This is very confusing, actually. Maybe I misunderstood this. I mean, clearly I misunderstood this a little bit. Because I also got it wrong here. Okay, maybe I just really misunderstood this problem. So you have one, you pay the cost of 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. That seems right. Why do I have 5 here? That's a little bit awkward. Huh. I think I'm misunderstanding this problem a little bit. Okay, so why can't you start at 0, index 0? You pay the cost 10, and then you go 2 steps, and now you're on the top. And this explanation is garbage. So, I mean, I'm still wrong here. I don't know why I'm getting 5 instead of 6. Am I misunderstanding something really weird? Maybe I am. So we skip cost of 3. So we go 1, 2, 3, 4, 5. Yeah, 5 is right. Why? Where do we get 6 from? Am I really misunderstanding this? Cost of the I've step on a stair. Because 5 should be right, but I'm wow, maybe I'm just really maybe my English is really bad today. Am I misunderstanding this one? So I think I'm right for some problem, but maybe it's not this problem. Cost where cost of I is the I. Cost where cost of I is the cost. So again, this is a good reminder that I am solving these live clearly. So if it's a little bit slow, just fast forward, and I don't know. I mean, you know the drill. So I still get comments about I should explain the problem earlier, but I'm like, I am solving these live. I'm sorry. But anyway, so okay, cost of I is the cost. I said once you pay the cost, you can climb 1 or 2 steps. The top of the floor. I see. I think I might get it now. I think it's just that the top of the floor is the thing that is higher than this step, right? So I think I get it. So instead of this, it should be this. Okay. And I guess this is n plus 1. I guess, but I think I think this is fine. It really disrupted my flow, but I think it's just they could have used one line to really explain it. I was just really confused by the English. Maybe well, I mean, I have days where I don't English very well, so I guess it is what it is. But okay, I mean, sounds good. Anyway, so moving right along to what we were going to say, which is that of course this branches out twice. Without memorization, this is going to give you an exponential thing, right? So given that n is at most 1,000, we don't even have to go that far. We just go, maybe big enough. Maybe this should be big enough, and it would already give you a time limit exceeded, as you can imagine. So then the next step, no pun intended. I'm a little phased now because of this. As we usually do on this channel, as you know, the next step is just recognizing that, okay, well, we use the step, the inputs for this function, step is going to happen multiple times, so let's save it down. So we can write is cached as you go to force, and we look at the number of possible inputs, and this can go up to from 0 to n, so it's going to be n plus 1 size, and cached as you go to, doesn't really matter, I guess, just infinity times n plus 1 as well. And then now you can start caching it. Which is that if this is cached of step, return cached of step. Otherwise, at the very end, we do is cached step is equal to true, and then we just cache the step, right? And that's pretty much it. Yeah, time limit exceeded. And then now, hopefully everything will be right. Unless I did something silly. Yeah, looks good. So let's give it a submit. And looks good. Yeah. So the number of possible inputs to min cost, and this is, of course, I probably should have mentioned in the beginning because that was the first thing I thought of, but I forgot to mention it, which is that obviously this has way, the complexity is way much the same as Fibonacci, right? Which is, of course, technically, you know, you can say it's 2 to the n, but technically that's not true. It's actually, you know, phi to the n or phi to the n or something like that. But that's close enough, right? Whatever. But anyway, my point is that in here, step can go from 0 to, is that 0? No, I will, oh, how did I write that? 0 to n, which means that there's big O of n, and each one of them takes O of 1 time, so it's going to give us O of n time in total, and also O of 1 space each input, so it's going to give us O of n space in total. So this is pretty straightforward, pretty elementary, and you probably need to know it because, well, look, like I said, this is at its core very much related to Fibonacci in a lot of kind of ways, and that is really fundamental. This is only a slight step up in difficulty, so you definitely need to know this for a competitive, for interview, for impressing your younger sister, whatever you need to do. Anyway, that's all I have for this problem. Hit the like button, hit the subscribe button, join me in Discord. Hope y'all have a great week, and I'll see you tomorrow. Bye bye.